In this video we are going to look at how to calculate relative atomic mass, and at the beginning we are also going to look at some of the theory behind relative atomic mass. All elements exist as a mixture of isotopes. We use this fact to calculate an element's relative atomic mass, and the abbreviation for relative atomic mass is RAM, or its symbol is AR. The relative atomic mass is the mean or average mass of an element's atoms. The RAM of an element is shown on the periodic table together with the atomic number. The equation to calculate relative atomic mass is RAM equals total mass of the atoms divided by the number of atoms. We are going to look at an example now. The abundance of the two isotopes of chlorine are 75% of chlorine 35 and 25% of chlorine 37. Calculate the relative atomic mass of chlorine. To do the calculation, we have to assume a certain number of atoms, and the easiest is to assume that we have 100 atoms, so we assume that we have 100 chlorine atoms here. If we have 100 chlorine atoms, 75 atoms are chlorine 35 and 25 atoms are chlorine 37. Now we're going to use those numbers to plug them into our equation. So RAM equals, we have 75 atoms of chlorine 35, so we have to plug those in for our mass, so we get 75 times 35. And then we also have 25 atoms that are chlorine 37, so we have to add those to the mass too, so we get plus in brackets 25 times 37. Now we still have to put in the number of atoms, and we assume that we have 100 chlorine atoms, so we just divide this by 100. Now we can start calculating. So we get, if we times together the numbers in the brackets, 2625 plus 925 divided by 100. This is 3550 divided by 100, and this gives us a relative atomic mass for chlorine of 35.5. Now let us look at a second example. Copper has two isotopes. 69% is copper 63 and 31% is copper 65. Calculate the relative atomic mass of copper. Again, to be able to do the calculation, we are going to assume that we have 100 atoms. So we assume that we have 100 copper atoms. Out of those 100, 69 atoms are copper 63 and 31 atoms are copper 65. Now with this information and the equation above, have a go yourself at calculating the relative atomic mass of copper. You can pause the video to do this. So again, we need to find the numbers that we need to plug into our equation. So we have RAM equals, we have 69 atoms that are copper 63, so in the first brackets we write 69 times 63. Then we have 31 more atoms that are copper 65, so we get plus, and then in brackets 31 times 65, divided by the number of atoms, that is 100, so we divide this by 100. Now we can start to calculate it, so if we times together the numbers in the brackets, we get 4347 plus 2015 divided by 100. That is 6362 divided by 100, and this gives us a relative atomic mass of copper of 63.62.